Hello friends, but just look at what a beautiful exercise we have here. We have a figure and we must find the shaded area. It simply gives us this distance, which is 2 meters. As always, you can solve it in your notebook and leave me your answer in the comments. Now let's move to the exercise. The first thing we will do is erase the shaded area and we will add it back at the end. Now what we're going to do is draw a line from this point here to here. So we draw that line straightforwardly. A right angle triangle is formed. Notice here there are 90 degrees. And if we draw another line from here to here, we get another right triangle. Let's do it well. This came out crooked here. Ready? Another right angle triangle is formed because here too there are 90 degrees. And the union of these two lines will also be 90 degrees. Whenever we join together on the perimeter of a circle, it gives us 90 degrees. Now what we're going to do is go labeling. Over here we have a small semicircle that we're going to assign the radius from the middle to any part of the perimeter is the radius that we will call small r, and it will be in green. And notice, if this is the radius and it measures r, then the diameter would be 2r, which goes from here to here. Here, and well, it's the base of this triangle here. This measures 12 there, which is the diameter of this small semicircle. Now, let's do the same with this medium semicircle. Notice here should be the midpoint. We draw a line. And this will be the radius of the medium semicircle, which will be in blue. And as we did here, so if this is r from here to here, uppercase r, then the diameter that goes from here to here is going to be 2 capital R's. Fantastic. Now what we're going to do is use the height theorem. The height theorem tells me that the squared height, let's name height as h. Ready? The height squared will be equal to the multiplication of these legs. Notice from this one to this leg here. Then from side A by side B, we're going to put it like a formula, right? So the height is 2 meters. We'll just put the number and at the end we'll add the units. Then it becomes 2 squared and this is going to be equal to this leg here, which is 2r, multiplied by this leg over here, which is 12 lowercase r. Very well, here we have 4 and over here we have 2 by 2. 4r, fantastic. Let's leave this here for now and we'll need it later. We'll continue over here by adding the shaded area. Notice the shaded area will be equal. Regarding the area of this large semicircle, then we need to find this area of the large semicircle that we are going to paint it a different color. The area of the big semicircle, we are going to paint it purple. P times radius squared divided by 2. Very good. Good. Less the area of the middle semicircle, which is this one here. So we have pi radius squared over 2 as well, because pi times radius squared is the area of a complete circle, and over 2 is half of a circle. And here you notice it's in blue. Not now. Let's place the formula here. From the area of this small green semicircle that we are going to put over here. So I have less left by the radius, and this radius is with a lowercase r squared over 2. Let's not get confused, this radius here with that radius there. That's why I used purple. So now we have that the area, because of the radius of this big semicircle, the one that covers everything, the one which is encompassing all the semicircles inside. So what will the radius of this be? We know the diameter. Notice the diameter will be equal to 12r. 2r, we're going to write it correctly. So 2r plus this part here, which is 2r. Very well then, but this is the diameter and the radius, well, of a semicircle, of a circle. Then its diameter over 2 is, this is the radius, isn't it? So that leaves me with 2r plus 2r. But this 2r plus 2r, we can take out the 2 as a common factor, leaving r plus r over this 2 here. We can simplify this and we have that. The radius, let's write it in uppercase. Since here it is capitalized, the radius of this large semicircle will be r plus r. This r here plus this r over there. So we're going to write it down with colors r plus r. Alright? Over here we have the radius of that semicircle in purple, which is the big one. No, is r plus r. And this is squared, right? All of this over 2. Now we're going to put over here, we don't know how much the radius of the small semicircle is, not from the medium semicircle, nor from the small one. So we're going to leave all this written exactly as it is. Less than pi times the radius squared over 2 and minus t times the radius with a lowercase r squared over 2. Very well. Okay, now everything we have here depends on the r's. We have here this r, then is the blue r. This r is the green r. So everything is under the same function. So we can just continue with a black pen. We have p halves and halves taking common factor, not in all terms. We have first, we open a parenthesis and put what's left over. In this case, it leaves me with ar plus r squared. It remains this way, r plus r squared, less than what I have here. If I remove the pi halves, I am left with r squared. Less than what I have here. If I remove this from here, I am left with simply r squared. Fantastic. Let's continue over here. The shaded area will be equal to half times. In parentheses here, we have a square binomial which unfolds as follows. The square of the first term is to say capital R squared plus 2 times the first by the second r by r. The second term squared, which should be r squared, and we put the rest minus r squared and minus r squared. So from here we can cancel out this r squared with this r squared. With this lowercase r squared, with this lowercase r squared. What we have left then inside the parentheses, we have 2r. Let's write it down so there is no confusion. So I have left pi halves, and inside the parentheses I have 2rr. Very well. Now so here we can simplify these two with these two, and now we're going back to the point where we found this part here. Notice here we have a r times r, and here we can also solve it, so it gives us r times r, and me here remains 4, and this 4 will stay on the other side dividing. 4 over 4 is 1, so we now know the value of r by r impressive is 1. 1, so I have 1 multiplied by pi, therefore the shaded area will be pi. Amazing exercise, we have found the shaded area of our exercise is pi meters squared. Let's return then the shaded area. All this part here, it measures an impressive pi square meters. Let me know in the comments if you liked the video, and don't forget to subscribe and hit like so you don't miss the next video. See you another time. Bye. Bye. Eso sí.